Greetings, sincere audience. I'd like to introduce you 7 basic quality control tools, which is the most useful of the quality management methods, and it has several impacts on the organization or company that concerning about the quality or anyone who like to working with the quality. Here are the founder of the quality management, Dr. Joseph Moses Joran, Dr. William Edward Deming. Dr. Kaoru Ishikawa was influenced by their publication and the articles. He was a chemical engineer working on the quality control in Japanese firms between 1930 to 1940. He had published a book with the title Genban no Kyushi Shoho in 1968. And it was about the quality management techniques and the practices that could be handled by anyone who had no knowledge about the quality control. The 7 basic quality control tools that was mentioned in the Dr. Ishikawa's book are the check sheet, histogram, Pareto chart, cause and effect or fishbone, scatter diagrams, flow chart or stratification nowadays, and the control chart. These are the 7 older versions of the basic control quality control tools. We have a newer version one that is called 7 management and the planning tools, containing tree diagrams, interrelationship diagrams, and the other tools that can be used in the quality management process. Total quality management was established in US Navy during 1980s. It has so many methods and the tools for controlling the quality. One of them is PDCA, that is the abbreviate of the Plan Do Check Act. The 7 basic quality control tools is one of the TQM tools that has a direct interaction with the PDCA. By the way, is there any benefits to learning the 7 basic quality control tools? My answer is yes, because it is less complicated than against the other statistical analysis, and it can be used by even average persons. With the good visual aids, the quality control is more comprehensible, and it can be used on vast majority of the quality related issues. To open up your mind, considering TQM as a solar system and the DMAIC, define, measure, analyze, improve, control, DMADV, define, measure, design, verify, PDCA, Plan Do Check Act, 7 basic quality control tools, even Six Sigma and other tools that was not mentioned here are just like a planets around it and has an interaction with each other. By classifying the 7 basic quality control tools, whether it is the identical or analytical, we can approach to this diagram that shows us which tools is absolutely identical or analytical or in middle of them. Without data, you're just a person with an option. It shows the importance of the data in William Deming aspect. So we should learn how to gathering the data. For gathering the data, we confront to 5 W's. That who's data taking, what data taking, where the data taking, when the data taking, and why the data is taking. These are the questions that must be answered. Gathering the data is the first step to get the first quality control tools, which means the check sheet. The check sheet is a formal sheet filled with the data. It has provide the historical records that may answering the 5 W's questions, and it can be used for further analysis. We use check sheet when the data are collectible or observable, or we can frequently collecting data. The most using of the check sheet is at the production process. For making a check sheet, first we should define the problem. Next, we should decide the duration of the collecting data. The next level is to design the form and labeling all the spaces on the form, testing the check sheet for a short time, and then recording the data on the check sheet. Here is a very formal form of a tally check sheet, which is collecting the project name, recorder, location, dates, defect types, day of the week, and even the total number. Here is the field 1 of the tally check sheet, which is one of the most useful check sheet, including defect location, tally check sheet, and defect cause check sheet. For a better check sheet, we should tailor it for a specific purpose, labeling the column and making it user-friendly. Before I get into the next quality control tool, I should ask you a question. In a town, the rate of the building churches and bars increased in 10 years. Is there any direct relation between them? I'm afraid so, because in 10 years, the population of the town increased too, so it affects on any rate of the buildings, including churches and bars. The purpose of the stratification is to divide the data, conquer the meaningful information to solve the problem. We can apply the stratification before the collecting data, or when the data come from the several sources or the conditions, such as shifts, days, day of week, supplies, population, or materials. The stratification procedure is to distinguish the data from various sources. The data that have been distinguished are stratified, and we can analyzing the rest of the data. Before the collecting data, the stratification process is to consider and examine the effectivity of the sources on results. For an example, here is a scatter diagram that shows us the purity of the products against the iron contaminant. At the first look, can we demonstrate any relationship between data? As a matter of the fact, no. But when one of the team members find out that the data comes from the 3 different resources, then we can find out some relationship. This process called a stratification. In a stratification, we should consider these type of the sources, such as equipment, shifts, department, materials, suppliers, day of the week, time of the day, and the products. The next quality control tool is about the independent and dependent variables, and we must find out the relation between them, or what is F? What can express F? Is it quantitative or qualitative? This can be answered by the Pearson correlation coefficient that varies between -1 to +1. Here is a 3 type of the scatter diagrams. The first one, when the independent and dependent variables increase and decrease, we have a positive correlation coefficient. But if the independent increase and the dependent decrease, or vice versa, we have a negative correlation coefficient. When we have a non-related data, the correlation coefficient is close to 0. But this is not the best answer for all type of the data in a scatter diagram. We have a nonlinear correlation that can be described by the Pearson correlation coefficient. We mainly use scatter diagrams when we have a paired numerical data or multiple values, which we want to find out the relation between the 2 variables. After collecting pairs of data where relationship is suspected and drew them on a graph for determining the relationship, we should use regression or correlation analysis. As you remember, the scatter diagram, we're going to find out the relation between the variables. We should dividing the scatter diagram into 4 fields. At first, we should count half of number of total points from up to bottom and drew a horizontal line after the last counted number. Then we should count half of the number of total points from left to right and drew a vertical line after the last counted number. The next step is to count the points in each quadrant and calculating the blue formulas. The final step is to look up on the trend test table and make a conclusion. For this example, the variables may have no relationship between them. The importance of the stratification showing up here, because if we stratify data, we can see that the reactor 2 and 3 have a negative correlation coefficient, which can't be discoverable by single regression or correlation analysis. On the next step, we reach to the histogram analysis, which is one of the most crucial tools of the quality control tools. It was constructed by the Carl Pearson, an English mathematician who has working on statistics in his major of lifetime. The histogram shows us the distribution of data and amount of variation during the process. We mainly use the histogram analysis for checking the shape of the distribution of the data, and it can be extended for the next or other analysis. As you remember this tally check sheet, here is the sheet filled with the data that we can now use it for making some diagrams. The first diagram is about the distribution of the defects. It has no information about the time, but still can be called histogram. The histogram of the defects variation. This diagram shows the number of the defects in order to the day of the week, which can be called the histogram of the defects over the time. The first step to construct a histogram is to counting the total number of the point. Here is the aperiodic data table that has the total number of the point 135. The next step is to summarizing or arranging data in a tally sheet. The third step is to compute the range. It can be obtained by the difference of the maximum and the minimum of the data. On the next level, we should determining the number of the intervals, and for that we have various choices. We can use the square root or Sturge's formula or Rice rule and some other formula that depending on the application. By using the recommendation, we can compute the width of the intervals and go to the next level. By determining the interval, a starting point, and counting the number of the points in each level, we can achieve that histogram, that proposed histogram. Every histogram type shape have a different analysis. The belly type shape distribution or the symmetric type is the standard type of the histogram. The skewed right shows us some missing in data or the problem in the collecting data process. The skewed left has a similar description too. The bimodal type occurs when the operator rounding some of the data, and the multimodal happen when the shifts are changing. In 2000, the US Census released a report of the travel time of 124 million Americans who travel between their work to home. It shows a bimodal type of the histogram
which means that the people who responded with travel time at least 30 minutes less than 35, but this likely due to people rounding their reported journey. The histogram also using to controlling the output by using the USL and LSL as a control limits. It helps us to find out is the process within the specification limit. The next quality control tool, which was constructed by the Wilfredo Pareto, is a chart. In 1906, when he was studied on the income distribution of the Italian people, we find out that the 80% of the wealth was in the hand of the 20% of the people. The 80-20 rule, or the Pareto principle, was developed by the Joran in 1915 and became one of the most useful quality control tools. The Pareto chart is the special type of the histogram which is following this principle, focus on the vital few instead of the trivial many. If we arranging the histogram in descending order of the height from the left to right and then drawing a cumulative graph of the data, we can reach to the Pareto chart. This is the Pareto chart of the last example that we have talking about. We use Pareto chart mostly when we want to focus on the most significant cause of the problem. Here is an example of the wasting of a bread in a bakery. We can see that first three items, which has the cumulative percentage more than the 80, are affecting all the outcomes. By reducing these three items, we can see a huge improvement in decreasing the bread wastement. The fishbone diagram, or the cause and effect diagram, was constructed by Kaoru Ishikawa, the versed scientist, in 1943 when he was working on the concept of the Kursey circle. We call it the fishbone because of the shape of a skeleton of a fish, and it helps us to find out a solution for our problems. We using the fishbone diagram when we want to identifying the possible causes of our problems. The most common causes for a manufacturer are coming from the 5 M's. The 5 M's are a stand for the machines, methods, materials, measurement, and the manpower. In other fields, like the product marketing, we have 8 P's, which are product, price, promotion, place, process, people, physical evidence, and the performance. And in the service field, we have 4 S's, which are surroundings, supplies, systems, and skills. To constructing a fishbone diagram, first we should agree on a problem statement or the effect. We drew a box on the right side and pointed with an arrow. On the second step, by helping 5 M's and brainstorming, we should categorize the causes of the problem. On the third step, we should write in the categories in order to the priority of each one against our problem and connect it to the main arrows. The fourth step is to brainstorming all the possible causes of each of our causes. And the final step is to focus attention to the places that the chart have fewer ideas. Here is a fishbone diagram for the example of the iron contaminant in our products. As you can see, each causes have sub-causes, and each sub-causes constructed by some other causes. The pre-structured fishbone that using mostly in manufacturing has the shape of this. The factors for controlling the defect X. As you can see the 5 M's, we have the environment items too. The two key questions that could be helping us for constructing our fishbone diagram are: how likely is this cause to be the major source of the issue or the variation? We should answer this question by very likely, somewhat likely, or not likely. The other question is: how easy would it be to fix or control? By answering these questions and gathering VV, VS, and SV, we can find out our causes. The final quality control tool is the control chart, or SPC, which is the abbreviate of the statistical process control. It was constructed by Walter A. Shewhart in 1920s when he was working in the Bell Telephone Laboratory. It is one of the most sophisticated tools for the quality management. The control chart is a special form of a run chart that is illustrate the amount and the nature of the variation in a process of the time. So we use the control chart when we want to determining the stability of the process. By identifying the UCL and LCL, which are the control limits of the chart, we can see if the chart is in control or out of it. By dividing the area into the 6 sub-area, we can have more accurate analysis of the controlling chart. As you can see, we have a 25 points that the number 16 is out of the control. For the conclusion section, we should say that it is very essential to apply all the 7 basic quality control tools for troubleshooting issues within the production process. According to the micro study, we can have a flowchart of how using basic quality control tools. On the final, thank you for your attention.